Attraction. Attraction is everywhere. Attraction of people, particles, and electrons. This attraction can make up families, planets, galaxies, and can even give you a slight electric shock. This shock is due to an electrical charge, which is the absence or excess of electrons, as seen in real life, especially as kids, when we were so entertained by rubbing a balloon on our hair just to see our hair stick up. It was the best. Anyway, this is due to a simple yet interesting interaction between two objects. One object is positively charged and negatively charged. The electrical charge is defined as the Coulomb bone. But one thing to consider is matter can also repel. There is also a field made by Coulomb. This field can be considered like a magnetic field made from a magnet, being that the south is a negative charge radiating inwards and the north is a positive charge radiating outwards. The electrical field can be defined as a field of force with a field of strength equal to the force per unit charge at that point. The electric field equation is E equals Fe over Q, which can become E equals K times Q over R squared. E represents the magnitude/strength of an electric field, and Fe is electric force, both being vectors. Q is a positive test charge, or charge producing the field, and K is the Coulomb bone constant. What is the magnitude and direction of the electric field 3 centimeters above a 34 microcoulomb charge? Now, magnitude means the strength/intensity in opposed to direction. Now, first off, to answer this question, we need to draw a positive charge with an electric field radiating outwards and the point 3 centimeters above. Q is the charge, and since it is micro, we get 34 times 10 to the power of negative 6 coulombs. Now we need to write out the equation E equals K times Q over R squared. Now putting in our numbers, we get 8.99 times 10 to the power of 9 times 34 times 10 to the power of negative 9 over 0.03 squared. Now, as you can see, the 0.03 is in meters, and it was in centimeters before. This is because in this distance formula, this needs to be meters, not centimeters. Now, we just put it into a calculator and get the answer of 3.4 times 10 to the power of 8 newtons over coulombs. An electron moving at 2.4 times 10 to the power of 6 meters a second enters an electric field that slows it. The electric field has a magnitude of 5,900 newtons over Coulomb bones. How far does the electron penetrate the field before it stops? Now, to work out this, we first draw a diagram. Now, this is not needed, but it helps to understand what the question is asking. To find the distance, we need to find the kinetic energy. So we use the equation Ke equals half m times v squared. Now, m is mass, and mass is the mass of an electron, is 9.11 times 10 to the power of negative 31 kilograms. Now we put our numbers in, and we end up getting 2.6 times 10 to the power of negative 18 joules. Now we need to find the force that is applied by the field on the electron. Now, to figure this out, we use F equals Q times E. Now we put in our numbers, and then we end up getting a calculation. And first off, you got to know that the charge of an electron is 1.6 times 10 to the power of negative 18 Coulomb bones. Now we put our numbers in and we end up getting 9.4 times 10 to the power of negative 16 newtons. Now we've got work and force. We put into the equation distance equals work, which is kinetic energy, over force. Now again, putting our numbers in, we end up getting 2.8 times 10 to the power of negative 3 meters. Now this is a very small number, but it is much energy for the electron to have. Electric current is the rate at which charge flows under the influence of an electrical field. That current can be either direct, with the net flow of the charge carriers moving in one direction, known as direct current, or alternating, which the carriers move back and forth periodically, known as alternating current. This can be displayed in an electrical circuit.
Thank you for listening to my video tutorial. Now, as you can see here, these are all the sources I have used to create this, as well as the Movely platform, which is the actual video tutorial creating platform I used. Now, as you can see here also, these are the photos links I've used. Now, the numbers of those photos are found in the bottom right hand corner of each photo in this video tutorial. Now, thank you again for listening.